Hello students, my name is Harish and today I'm going to explain you the topic heating effect of electric current. Okay, this topic is from the chapter electricity. Now you see, when a voltage source like a battery, okay, it is connected to a circuit. Obviously, it generates the current for a circuit, right? And it has some chemical energy inside, right? So the energy is used up in maintaining the current inside the circuit. For example, if you see a circuit with a bulb and a battery, in that case, the energy of the battery is used up by the bulb to glow, right? Or if you connect the battery to a fan, in that case, the energy of the battery is used up by the fan, right? Similarly, if you draw a circuit which has only resistors in it and battery, in that case, all the energy of the battery is dissipated in the form of heat. Do you understand? And this is what is known as heating effect of electric current. So what exactly is heating of electric current? When you connect a battery to only resistors, in that case all the energy of the battery is used up by the resistance to dissipate it in the form of heat. Okay, actually, and this phenomenon is used by many devices in real life. Okay, you will understand about that later. For now, just remember the definition of heating effect of electric current. Okay, now let us look into the scientific formula side. Okay, how do we derive the formula for this heat? Right. See, first of all, you all know that power is equal to work done upon time, right? So power is equal to WIT. And we also know the definition of potential difference. What is potential difference? Potential difference is the work done to bring a unit charge from one point to another. So here, that potential difference V will be W by Q. From here, you can get the work done is equal to V into Q. Now, if you substitute that into the equation of power is equal to work done upon time, you will receive a new equation, that is power is equal to VI, where I is the current and V is the voltage difference. Okay, so power is equal to VI. Now, so basically for a steady current I, the amount of heat produced in this time for time t, that is equal to heat is equal to V into I into T. What exactly is this equation? Here, heat E is equal to power into time. Do you understand? And the power we got the equation as VI. So heat is equal to V into I into T. Okay, and now if you substitute the Ohm's law into this equation, that is V is equal to IR was the equation, right? You substitute it into this equation, you will get heat is equal to I square RT. And this is what is known as Joule's law of heating. Okay, I hope this point is clear. Now let us look more into Joule's law of heating. From Ohm's law, we got this equation that heat is equal to I square RT. This implies that the heat produced in a resistor is directly proportional to the square of current for a given resistance, I square. We can see that it is directly proportional to the resistance for the given current, that is R. We can also see that it is directly proportional to the time for which the current flows through the resistor, that is T. That also we can see that. So this equation heat is equal to I square RT is a very important equation which you will have to remember. Okay, and this Joule's law of heating tells us how this is related to all these terms. That means the heat is related to all these terms. The basic equation is heat is equal to I square RT. Okay. Now, what are the practical applications of heating of an electric current? Now, as I said that the energy of the battery is in this case used up by the resistor to dissipate it in the form of heat. Am I right? So the battery of energy is used to convert it into heat. Now, if you notice the example of a bulb, okay, in bulb there's a tungsten wire inside it, okay, and when this wire becomes hot, it emits light, okay, that is how the bulb grow. So basically, when you connect this bulb to a circuit, The tungsten wire converts the energy inside the electric source into heat, and this heat is converted into light. So basically, the bulb uses the heating effect of electric current phenomena. So one of the biggest example for practical application of heating effect is a bulb. And how does it do it? There's a tungsten filament inside the bulb, okay, that converts the electric energy of the battery, which the battery provides, into the heat, right? And this due to this heat, that the bulb starts to glow. Okay. Other examples of this are the bread toaster, which you use in the morning, and also the iron. In this case, also the electric energy is converted to heat. Okay, the electric current is flowing, the converted to heat and is dissipated. Right? That's why the iron box is hot. That's why your bread becomes hot because of the toaster. Right? And one of the biggest use of Joule's heating law is that it is uses in fuses. If you know what fuse is, that when there is a sudden jerk in the current that is provided into your house or something like that, and these things are very harmful for your devices. This can make short circuit. These things are very very harmful. So that is why you infuse fuse in them. When you infuse fuse in them, this fuse will melt. And how will it melt? It will melt because of the heating effect of the electric current. So when there is a higher amount of electric current in that wire, which is more than required, so it will dissipate more heat. And due to this heat, our fuse will start melting, and this will block the current inside the wire. Okay, so the current will not flow anymore. So your devices are saved right now. So that is how you use fuse. These fuse wires are always made up of thin aluminum, copper, etc. Okay. So if you notice here, it's been mentioned that these wires melt and break the circuit due to heating during excessive current. So when there is more current required in that wire, this fuse element will melt because of the heat, and the circuit will be short circuited. The current won't flow. So it won't be harmful for your house or your devices. Okay. Thank you.